Referring back once again to our solution to the first problem, where our general solution was C1 e to the t times this vector, etc. I'm going to form what we call the psi matrix, our solution matrix, the matrix whose columns consist of the solutions of our system, or rather a matrix whose columns consist of a fundamental set of solutions. Okay, so columns consist of a fundamental set. Remember, when we solved these equations, we had some arbitrariness in our choice of the x1, x2 vectors. We could have chosen any multiple of any of those vectors, so that this is not our only possible solution matrix. And we might be better off to call this a fundamental matrix. So maybe we want to get rid of the word solution and call it fundamental, to emphasize that this should be a fundamental set. Now, if we take this matrix, whose first column is one of the solution vectors, e to the t, negative 2 e to the t, and the other is the other fundamental solution vector, e to the 7t, e to the 7t. If we multiply this by the column vector c1, c2, what we get is, of course, this matrix multiplied by c1, c2, and what's that? Well, if we multiply e to the t by c1 and e to the 7t by c2, to get the first row of our product, we have c1 e to the t plus c2 e to the 7t. And if we multiply the second row by our c1, c2, we have negative 2c1 e to the t plus c2 e to the 7t. I didn't leave myself enough room, so I had to write that way too small. And this is our general solution, which we've seen 2 or 3 times by now. So, for y1 equal to this function, y2 equal to this function, our notation is going to be psi of t equals the matrix y1 comma y2, where y1 is a vector that we represent as a column, so that y1 becomes this column in agreement with this, and y2 becomes a column represented like so in the matrix, so that the column vector is as we say it is. Now, in general, if we had a system of n equations and n unknowns, if we have a fundamental set y1, y2 through y sub n, then our fundamental matrix psi of t would be represented by y1, y2 through y sub n, and psi of t times a vector of n constants, c1 through c sub n, would equal c1 y1 plus c2 y2, and so forth up to c sub n y sub n. This is merely a notational convention and a notational convenience, but you need to be aware of this kind of notation. Otherwise, when you see a matrix that looks like this, you might have difficulty understanding just exactly what you're looking at.